Hello students, myself Mohammad Ashraf Khan, and today I am going to teach you oxidation number. Students, in my last lecture I took few examples, and with the help of those examples I explained you how to calculate oxidation number. One more thing I want to tell you, I am continuing from that part, that the charge present on ion, for example, this is sulfate ion. The charge present on ion is equal to the sum of all the oxidation number present on the atoms. For example, I have to find the oxidation number of sulfur here, then I assume it is X, then I write plus, then this subscript we write here first, and then we write the oxidation number of oxygen. The sum of these all oxidation must be equal to the charge present on the ion, which is -2 here. So x minus 8 will be -2 and 8 will be equal to +6. Is it clear? Similarly, there are many types of ion. For example, this is called sulfate ion, SO3 2 minus, sulfite ion S2O3 2 minus, thiosulfate ion CO3 2 minus, carbonate ion NO3 minus, nitrate ion NO2 minus, nitrite ion. Similarly, Cn minus, cyanide ion. Nc minus is isocyanide ion, and CnS minus, thiocyanide ion. NCS minus, isothiocyanide ion. CNO minus, cyanate ion. NCO minus, isocyanate ion, and NH4 plus, this is called ammonium ion. CH3 plus, this is called methyl ion. Okay, here methyl carb cation. N3 minus, this is called azide ion, AZID, azide ion. Similarly, N3 minus is called this is not azide, this is nitride. This is nitride, and this one is azide ion. N3 minus 1, N minus 3 is called nitride ion. So students, in different type of ions, whatever the charge is present is called or is equal to the sum of all the oxidation numbers. I hope you understood. And students, one more thing, you have to memorize these all ions. Some are like phosphate ion, PO4 3 minus ion, this is called phosphate ion. And like ClO4 minus, this is perchlorate ion. ClO3 minus, and this is called chlorate ion. Okay, there are many more examples. I will send you the list of all these ions. Now I take one more example of, for example, H2S2O7. This is called oleum. If I ask you to find the oxidation number of sulfur in oleum, then how you can find is very simple. First we write 2, then we write oxidation number of hydrogen here, then plus, then we write 2, sulfur we don't know, that's why I write X, plus we write 7 here, and oxidation number of oxygen, and the sum of these all must be equal to 0. Now this one become +2, this one is 2x, this one minus 14 is equal to 0 of 2x and plus 2 minus 14 will be minus 12, and if I shift minus 12 from here to means left hand side to right hand side, it will become plus 12. So I write here plus 12. The X will be equal to plus 6. Oxidation number of sulfur is plus 6. Is it clear, students? But this is also called disulfuric acid. Okay, disulfuric acid. And another example I take H2S2O8. This is called peroxy या peroxo disulfuric acid. The name suggests here that there is a peroxide bond. As you can see, peroxo means there is a peroxide bond. The name of this compound oleum can be written as disulfuric acid. Okay, disulfuric acid, the name is because two H2SO4 molecules, they combine with each other and removal of one water molecule takes place from here. Okay, one water molecule remove and then these two molecules get combined or joined with each other. So how many H2 remaining? Minus H2O, total 4, and minus 2. So how many hydrogen left? Only 2. Sulfur how many? 2. Oxygen total 8. Here minus 1. So oxygen becomes 7. So this is how we write the formula of oleum. Now in this case, if I write 2 plus 1 for hydrogen plus 2x for sulfur and plus 8 minus 2 is equal to 0. 2x will be equal to plus 14 and x will be equal to plus 7. This is wrong, completely wrong, because sulfur oxidation number cannot be more than plus 6. As I told you already, then what we are supposed to do? We have to find we have to write the structure of peroxodisulfuric acid first. So we have to write the structure first. Students, in order to draw the structure, we have to find the central atom first. In this case, H2S2O8. This one is also having one name, peroxodisulfuric acid, and we call it as Marshall acid. Marshall acid. So sulfur is the central atom. So we have to write first sulfur. Okay, sulfur and sulfur. Now the number of hydrogen here, if 2 or whatever the number of hydrogen in acids of sulfur, they must be attached with oxygen. Here 2 hydrogen means they will get attached with 2 oxygen first. And how many oxygens are here? 8. So total 8 oxygens are present here. But remember that valency of sulfur is maximum is 6. So bonds of sulfur cannot be exceed from 6. So I make one bond here, one here, one here, one here, one here, one here. Total 6 oxygen I have arranged, but still left 2. Okay, never mind. We will set 2 oxygen later. Here hydrogen can only be attached with oxygen. So I attached with oxygen this hydrogen, 2 hydrogen atoms. Hydrogen can form only one bond. That's why I write one bond here, and for this hydrogen one bond here. For this oxygen, valency is satisfied. Okay, oxygen can form maximum 2 bonds, but here and here they are not satisfied. So I write one more bond here. Now students, this oxygen valency is satisfied. For this one also satisfied, this one also satisfied. So all the oxygen have satisfied valencies. Sulfur 2, 3, 4, 5. Total how many bond? 5. So we can form maximum one more bond, but we are left with 2 oxygen. Now how we can attach 2 oxygen in this structure? So if I write one oxygen here and bonded with this sulfur, then this one will be the structure of this oleum. Okay, H2S2O7. Okay, is it clear? But here O8, one more oxygen is here, so I add one more oxygen here. Now student, you can see total bond of sulfur is 6. It is good. For this oxygen is 2 bond, this oxygen also having 2 bond. So here valency of all the atoms is satisfied. So we can say that our structure is correct. But students, if I remove one oxygen, it will become oleum or disulfuric acid. Oleum is also called one more name pyrosulfuric acid. If you add two molecules and remove water, then we can use term pyro as a prefix of the name. So pyrosulfuric acid or pyro-disulfuric acid, we can say pyro. We say if we say pyro, it means it is disulfuric acid, pyrosulfuric acid. Is it clear? So oleum is also called pyrosulfuric acid, and this one is peroxo, means there is a peroxide bond. So we can find here is peroxide bond. When oxygen attached with oxygen, it is called a peroxide bond. So oxidation number of this oxygen is -1. For this one is also -1. Is it clear, students? So two oxygen have -1 and -1, total -2, and rest of the oxygens are simple oxides. Okay, so their oxidation number can be written as -2. What about hydrogen +1 and hydrogen +1? So I write oxidation number of all the oxygen atom remaining. Now you add all the oxidation number. Okay, this -1, this -1, -2, -2, -2, -2, -2 and +1 and +1. The total of all the oxidation number is -12. The total is -12. So opposite must be of these two sulfur, only sulfur, two sulfur atoms here. So the total of all the oxidation number here -12. So on these two sulfur, the oxidation number total must be +12, so that this will become 0, because one molecule on the total of all the oxidation number of any molecule is equal to 0. Here all other atoms have -12 oxidation number. So what will be the oxidation number of these two sulfur? +12. So one sulfur will be +6 and another sulfur will be +6. Is it clear? Or you can do in this way also. You can split this molecule. Now you see total how much? -2, -2, -2, -6, -1 +1 cancel each other. Okay, so -2, -2, -2, -6. The oxidation number of sulfur will be +6. Similarly here. So we can solve in this manner also. Is it clear, student? And I can take some more examples, but you try by yourself. So students, our topic next is balancing redox reaction. This is very important topic of this chapter. So in balancing redox reaction, we can use two methods. The first one is ion electron method. This one is also called half reaction method. Half reaction method. And the second one is oxidation number method. Oxidation number method. First, we will balance the redox reaction by this method, ion electron method or half reaction method. So I write half reaction method. I take one example and solve the reaction with the help of this method. For example, I write Cr2O7, 2 minus plus Fe3 plus gives Cr3 plus Fe2 plus in acidic medium. In these reactions, we can take two medium, in acidic medium and in basic medium. So I I solve this equation in acidic medium first. So student, before starting, what we have to do, we have to find the oxidation and reduction reaction. Because this is a redox reaction, so half oxidation and half reduction is taking place in this reaction. I write oxidation number of chromium first here. So oxidation number of chromium can be written for this one, 2x plus 7 minus 2 will be equal to minus 2. So x will be equal to how much? Plus 6. Okay, so I write plus 6 here. This is the oxidation number. This is charge. Please don't touch this one. Okay, this is charge and this is imaginary charge. That's why it is called oxidation number. Now come here, plus 3. What is happening? Decreasing oxidation number. Means here it has deficiency of 6 electron. Now here chromium have only deficiency of 3 electrons. So it gains 3 electron. It means it is gaining 3 electron, and gaining electron is called what? It is called reduction. Yes, correct. So Cr2O7 is undergoing reduction. Okay. Now what about this one? Plus 3. Sorry, this one must be plus 2. This one will be plus 3. Here losing of electron taking place. Losing of electron. Plus 2, lose 1 electron and convert into plus 3 ion. So here gaining of electron taking place, here losing of electron taking place. So losing of electron is called oxidation. Okay, and this is reduction. So we have to write first these two things, that Fe2 plus getting oxidized into Fe3 plus and Cr2O7 2 minus getting reduced into Cr3 plus. Whatever the charge is present is oxidation number of that ion. Okay, so if this one is getting reduced, then we can say this is a oxidizing agent. This is oxidizing. And what about this one? This one is reducing agent because it is undergoing oxidation. This one I explained you already. Now we have to write the two reactions separately. First I write reduction half. Reduction half reaction. I am going to balance reduction half first. Okay. Similarly, I will do the same with oxidation half reaction also. So in reduction half, what we are supposed to do, we have to write this equation again. Cr3 plus. This is reduction half, and Fe2 plus to Fe3 plus is oxidation half reaction. So we have to balance this equation first. In the first step first, we balance metals. Okay, means first we balance the atoms other than oxygen and hydrogen. Balance atoms other than oxygen and hydrogen. Here 2 chromium, here only 1 chromium. So in order to balance this chromium, we can write 2 here. This equation will be Cr2O7 2 minus 2Cr3 plus. Now as you can see students, that chromium is balanced. Next is oxygen. So step second is balance oxygen. Please remember these steps, these are very important. Balance oxygen by adding water. Okay, here how many oxygen total? 7 oxygen. So we can add 7 water molecule here to balance oxygen. How? See here, plus 7 H2O. Now we are total how many oxygen? 7. Here also 7, means oxygen is balanced. Chromium is already balanced, oxygen balanced. Now here we got one more atom of hydrogen. So we have to balance this hydrogen. So in step third, balance hydrogen by adding H plus ion. Okay students, now again we have to write this equation by balance. So here how many total hydrogen? 14. 7 to the 14. So I write 14 H plus Cr2O7 2 minus gives you 2Cr3 plus 7H2O. Now students, all the atoms are here, all the atoms are balanced here. 14H, 14H, 2Cr, 2Cr, 7 oxygen, 7 oxygen. Now we have to balance in step 4, balance charge. Balance charge by adding electrons. By adding electron. Student, remember, electron is considered as -1 charge. One electron is considered as -1 charge. Now here total how many charge? Plus 14 charge. Okay, 1 hydrogen plus 1, 14 hydrogen plus 14. Now here how much charge? -2. -2. Now total how much charge? 1 chromium plus 3, 2 chromium plus 6. Okay, now here plus 12 and here is plus 6. Now we have to add electron in order to balance charge. Electron have -1. Here plus 6. If I write -6 here to balance, it will be cancelled. Here charge will be 0. So here I cannot write -6. I add 6 electron on this side. Okay. So what will be the charge of this 6 electron? -6. Okay, 6 electron -6. So here total charge will be equal to plus 6. Now charge is balanced. So this is our equation number 1. Is it clear? Now students, I am going to balance this reduction half is balanced. Now balance the oxidation half. Oxidation half reaction, which was Fe2 plus to Fe3 plus. Okay, now this one is very simple. First we have to balance the atom other than oxygen and hydrogen. Here is only one Fe, here is only one Fe. Now balance oxygen here, because oxygen is absent we cannot balance. Then we have to balance hydrogen. Here is no hydrogen in this equation, so hydrogen cannot be balanced. Now the only thing is left, charge. Here charge is +2 and here charge is +3. Now we have to add electron in order to balance this charge. So I add 1 electron here. Okay, 1 electron charge will be -1. So here total charge will be +2, here also +2. So it means charge is balanced in this reaction. Now what we do, we have to write these two equations again. Okay, but before writing we have to multiply it with the suitable number. Means we have to balance in the last step, step 5, balance electron by multiplying with suitable number. Okay, so in order to balance electron, I multiply this equation with 6. Okay, I multiply. So I multiply and then write again. So I write first equation first, plus 14H Cr2O7 2 minus 2Cr3 plus 7H2O. Now I multiply this equation with 6 and write again. It will become 6Fe2 plus gives 6Fe3 plus 6 electron. Now what we have to we have to add these two equations. Student, remember, if 6 electron is on left hand side and 6 electron on right hand side, we can cancel each other. Similarly, like 2 is equal to 2 plus x plus y, suppose. Okay, these two cancel with these 2, because if you move plus 2 from here to here, it will become minus 2. The plus minus will be cancelled. So in the same manner, plus 6 if on the right hand side and plus 6 electron on left hand side, they can cancel each other. Okay, now whatever the thing on the left hand side, I have to write all the things here. 14H plus Cr2O7 2 minus plus 6Fe 2 plus, and I write here what is 2Cr3 plus 6 Fe3 plus and 7 water molecule. Student, remember, if suppose there is 7 water molecule and here 4 water molecule, 4 here and 7 here, then 4 we have to write in this way, the 7 minus 4 water molecule. Only we have to write left in the water molecules. Okay, here left maybe 3 if there is 4. If there is 7 water molecule, here also 7, then can be cancelled with each other. Similarly with hydrogen also, if on left hand side is 14 hydrogen and let's say on this right hand side is also 14 hydrogen, then we can cancel 14 hydrogen with each other. But suppose here is only 8 H plus. The 8, if you transfer 8 from this side to this side, 14 minus 8, now here left only 6 H plus. So in this case we have to write only 6 H plus if there is 8 H plus. But right now there is nothing, just I am telling you, you have to remember this thing. Okay, rest of the things we cannot change, only electron, H plus and water molecule. Okay, so this equation now is completely balanced. Now how to check that equation is balanced? We have to check the charge. If total charge is same, it means our reaction is correct. Okay, now here total charge is plus 14 minus 2 and 6 to the 12, total 12. So how much here charge? Plus 24. Now calculate here, plus 6, okay, plus 18, 6 3 is 18, total charge plus 24. Charge is balanced, it means our reaction is completely balanced. So I hope you understood. Thank you very much, and try to watch it 2 or 3 times, then you will be able to understand easily. In my next lecture I will explain you one more example, and before that I want to give you one example so that you can solve by yourself. I give you one example of like that. Cr2O, no, this one not good. You try to solve. Yes, CrO4 2 minus plus SO3 2 minus gives CrO 2 minus plus SO4 2 minus in acidic medium. Student, try to solve this equation in acidic medium. Okay, this is 2 minus. I hope you understood. Thank you very much. Bye.